Hello again. In this video, I'm going to go over this homework problem from 2.3. And in this problem, we're supposed to evaluate this limit. Now, there's various ways of evaluating a limit. You could create a table, you could use substitution, and sometimes we graph the function and look at the graph to determine the limit. In this case, I am going to use the substitution method to evaluate the limit. Now, when you use the substitution method, you have to be very careful about how you interpret what you're doing when you use the substitution method. So basically the idea behind the substitution method is we're going to plug in, like x is approaching 25, right? And so as x is approaching 25, we're supposed to determine as that happens what this function is going to get closer to, right? What the output of this function is going to get closer to, which I call the y value. So as x gets closer to 25, we're supposed to determine what the y values are getting closer to for this particular function. So in essence, we need to plug in, like if we were to create a table to evaluate this limit, we would plug in numbers close to 25. So we might plug in 24.9, for instance, and you would plug that in to the top and the bottom here, right, for x. And then you plug that into a calculator and you look at what number comes out, and that would be the y value, the corresponding y value when x is 24.9. Okay, and then you get closer to 25, so then you would pick an x value of something like 24.99, and then plug that into the function and see what y value comes out. And you continue to do this and look at the y values. So you plug in 24.999 and look at its y value that comes out. And then you start to look at all the different y values that are coming out and try to determine what they're getting closer to. And whatever number the y values are getting closer to would be the limit. Of course, you need to do this, that would be the left side limit, approaching from the negative side. You would also have to do this from the positive side and plug in numbers above 25. So like 25.1, and then 25.01, and then 25.001. And so once you have the left side limit and the right side limit, if those two numbers are the same, then that is the two-sided limit. Okay, well that's not a very elegant way of evaluating limits. Creating a table requires you to use a calculator, and you'd have to punch in all these decimals into the calculator, so it's very tedious and kind of grubby. That's where the substitution method has an advantage, because it's not so grubby, but you have to be careful about how you interpret what you're doing when you use the substitution method. So here's what we're going to do instead. Using the substitution method, what you can do is you can plug 25 in, even though you're not supposed to, because that's not what the limit is asking for, right? What the limit is asking for is what the output values are getting closer to as x gets closer to 25. At no point will x ever reach 25 here. It just gets closer to 25. So technically, we're not supposed to plug a 25 in. But we're going to do it anyway, and then we're going to try to interpret what that means when we actually plug the 25 in. Okay, so if you were to plug a 25 into this, notice on top you would get square root of 25, which is 5, and then 5 minus 5 is 0. And likewise, if you plug 25 into the bottom, 25 minus 25 is also 0. And so you get 0 divided by 0. Now, if this is just a function and I evaluate it at 25, right, I plug 25 into it, then the output would be 0 divided by 0, which is undefined because you can't divide by 0. So f of 25, f evaluated at 25, is undefined. There's no output for 25. You input a 25 and there is no output because you get 0 divided by 0. So technically speaking, if I were to plug a 25 into this function, I get 0 over 0, which is undefined. Okay, having said that, we're not really trying to find f evaluated at 25. We're just plugging 25 in to help us evaluate this limit. So here's how you interpret what happens when you plug a 25 in. On the top, when I plug a 25 in, I get 0. Well, what that really means for me in terms of understanding this limit, it means that the top is getting closer to 0 as x gets closer to 25. And likewise on the bottom, right? If I plug a 25 in, I get 0. But in this particular situation, the way I interpret that in terms of this limit is that as x is getting closer to 25, the bottom is getting closer to 0. So here's the overall interpretation. When I use substitution and plug 25 in to this function, I get 0 over 0. What that means, the way I interpret it to help me evaluate this limit, is that as x is getting closer to 25, the top is getting closer to 0, and the bottom is getting closer to 0. And that's called an indeterminate form when that happens. Now remember, I'm not supposed to plug 25 in. What I really should be plugging in is like 24.9 or 25.1. And for that reason, I will never reach 0 on the top or the bottom. So what's really happening is I'm getting closer to 0. So you need to think of the top as being like 0.001 and the bottom being like 0.001. They're getting closer to 0. Okay? And they will never reach 0 because x will never get to 25. Okay? So that's what I want you to be careful about. So again, I'm going to use substitution to evaluate this limit. I plug 25 in, and I get 0 over 0, and that's called an indeterminate form. Essentially, what that's saying is I can't use substitution to evaluate this limit when the function is written in this particular form. Okay, and so if you ever get an indeterminate form like 0 divided by 0, when you're trying to evaluate a limit using substitution, then what you have to do is you have to rewrite the function in a different form so that it's determinable when you use substitution. Okay? So that's what we're going to do now. So what I'm going to do is take this function and I'm going to try to rewrite it so that we can evaluate the limit using substitution. In other words, it becomes determinable when we substitute in for 25. Okay, so here's what we're going to do. So let me just write this down. We have square root of x minus 5 divided by x minus 25. Okay, so I'm just going to manipulate this function to a different form. Okay, so what I'm going to do is I'm going to multiply by what's called the conjugate from the top. Okay, so the conjugate of the top piece is the square root of x plus 5. Okay, and it's called the conjugate. When you change the sign of one of the two terms here, it's called the conjugate. Okay, so I changed this negative sign to a plus sign. And so the square root of x plus 5 is called the conjugate of the square root of x minus 5. That's called the conjugate. Now I can't just multiply by that because then I would change the value of the original function. So if I'm going to do that, I really need to divide by the same thing. Because if I do that, then this is equal to 1, and I can multiply the original function by 1 without changing its value. Okay, all I'm doing is changing the form. The value remains the same if I multiply it by 1. Okay, so I'm just going to FOIL the top out. So we're going to take, first, outer, inner, last. Okay, so the first would be square root of x times the square root of x. And that's just equal to x. Okay, then the outer would be square root of x times 5. So 5 times the square root of x. Okay, and then the inner would be negative 5 times the square root of x. Okay, and then the last would be -5 times +5, which is -25. Okay, and then on the bottom, I'm not going to FOIL that out. I'm just going to write that as, again, x minus 25 times the square root of x plus 5. Now notice on top, after you FOIL that out, that this 5 times the square root of x cancels with the -5 times the square root of x. And that just leaves you with x minus 25 on top. And that's going to cancel with the x minus 25 on the bottom. Okay, and so those cancel out. And of course, when those cancel out, you're left with a 1 on top. It's actually 1 divided by 1, right? Since that's equal to 1. So you're left with a 1 on top. And so all I've done here is the original form that I had, this function here, that's the same thing as this. They're equal to each other. So then when I go back to evaluate the original limit, the limit as x approaches 25, instead of substituting into the original function that we were given, we can substitute it into this manipulated function that it's equal to. Okay, so 1 over the square root of x plus 5. Okay, so we're just going to evaluate that limit. And whatever this limit is, it's the same as the original limit that we were trying to find, since the original function is equal to this function I have here. Okay, so now let's try substitution now. So if I were to plug 25 in for x, notice that I would get 1 over the square root of 25 plus 5. And of course, the square root of 25 is 5, so that's really 1 over 5 plus 5, which is 1/10. Okay, so just to kind of put a cap on this problem, the original form that we had for this limit, when we used substitution, we got 0 over 0, and that's an indeterminate form. And so we had to manipulate the function to a different form, and we did that by multiplying by the conjugate on top and bottom. And then that gave us this new form of 1 over the square root of x plus 5, and now we tried to evaluate the limit using substitution again, but this time it was determinable because when I plugged 25 in, I got 1/10. And so that's what the limit is equal to. The original limit that we had is 1/10. Okay, so I hope you found this video helpful, and I'll continue to do some more from this chapter. Bye-bye.